The number of bacteria N present in a culture can be modelled by the equation N equals 7,000 plus 2,000 e to the negative 0.05 t, where t is measured in days. We want to find the number of bacteria when t equals 10. So that's really straightforward, which is why it's only 1 mark. We're just going to substitute in. So we've got 7,000 plus 2,000 e to the negative 0.05 times 10. And we just need to calculate that. So let's bring in the calculator. And we've got 7,000, add 2,000 times e to the negative 0.05 times 10. And that is going to give us 8,213. So we'll say approximately 8213. So let's look at part 2. The value of t when the number of bacteria reaches 7,500. So 7,500 will be equal to 7,000 plus 2,000 e to the negative 0.05 t. So we've got to solve this equation basically. Well, the first thing is we can divide through by 100. So 75 is 70 plus 20 e to the negative 0.05 t. Subtract 70 from both sides. 5 equals 20 e to the negative 0.05 t. Divide both sides by 20. So that would give me 0.25, so 5 over 20, which is a quarter, is e to the negative 0.05 t. Take natural log of both sides. Log of 0.25 will be the natural log of e to the negative 0.05 t. Now we know the natural log and the exponential function are inverse functions, so that right hand side is just going to become negative 0.05 t. And so t is going to be the ln of 0.25 divided by negative 0.05. So we can calculate that. So we have natural log 0.25 divided by negative 0.05, and that gives us 27.72 725, so we'll say 73 to 2 decimal places. And we know from earlier in the question that that's in days, and perhaps we should state that here. So I'm just going to say days to 2dp. Okay, so the rate at which the number of bacteria is decreasing after 8 days. So rate implies we've got to differentiate. So we know that n was equal to 7,000 plus 2,000 e to the negative 0.05 t. So dn dt is going to be, well, the 7,000 will disappear, and then we'll get the 2,000 e to the negative 0.05 t. Remember how the exponential differentiates. So the power here, the index, is always going to stay the same. But then we need to use the chain rule. So we multiply by the differential at the inside, which is negative 0.05. And so if we just quickly do 2,000 times 0.05, that gives me 100. So we've got negative 100 e to the negative 0.05 t. So now we want dn dt evaluated when t is equal to 8. So that's going to be negative 100 e to the negative 0.05 times 8. So what have we got? Just do 100 multiplied by e to the negative 0.05 times 8, and that gives me negative 67, and that would be bacteria per day. And I've given that once again to 2 decimal places.